Hello everyone. Last class I had done types of many functions. Last I taught you as largest integral function and smallest integer function. Today I'll start with exponential function. What is exponential function? Now exponent means power. Now a function f mapping from R to R is defined by fx equal to a to the power x is exponential function where a is positive real number, and a is not equal to 1. This a is not equal to 1. Here domain is R and range is 0 to infinity. Both are excluded as it attains only positive value because the range attains only positive value. So it comes from 0 to infinity. Now, there are two cases in exponential function. What are the cases? Cases is if a is greater than 1 and here x lies between your 0 and 1. Now this, if a is greater than, then y equal to fx equal to a to the power x increases with increase in value of x. What happens? Y equal to fx to the equal to a to the power x increases with increase in value of x. Now, if fx equal to a to the power x, that is less than 1 if x is less than 0, and equal to 1 if x equal to 0. Here equal to 1 if x equal to 0, and if x is less than 1, it is also y is also less than 1. And if x is greater than 1, then it increases. That is why it is x is greater than 1, then means it is x is greater than 0, it is greater than 1. So three conditions. If x is less than 0, x is less than 0, it is less than 1. If x is equal to 0, then it is equal to 1. And if x is greater than 0, then it is always greater than 1. The graph will be like this. It increases. Now, second condition. Case 1, case 2. If x lies between 0 and 1, then y equal to fx equal to a to the power x. The value of y here decreases. Value of y decreases with increase in value of x. What happens here? In first case, the value of y increases with increase in value of x, and here the value of y decreases with increase in value of x. Or here y is always greater than 0. That means y is always positive for x belongs to real. For any x belonging to real number, that is for any real x, y is always positive. It does not become less than 0. Now that is function is fx equal to a to the power x. It is greater than 1 if x is less than 0. It is greater than 1 here. It is 0 1. It is greater than 1 if x is less than 0. Now it is equal to 1 if x is greater than equal to 0, and also last it is less than 1, that it decreases when x is greater than. So these are two exponential functions. What are the conditions are? The first one and second one. Here y increases with increase in value of x, and here y decreases with increase in value of x. But this is correct. Y is never less than 0 or equal to 0. It is always greater than 0. That is, it is always positive for any x real number. Let's move to logarithmic function. What is logarithmic function? A function f mapping from 0 infinity to r. There it was exponential r to 0 infinity. Here the 0 infinity to r defined by fx equal to log x to the base a is called a logarithmic function where a is positive real number. This a is positive real number and a is not equal to 1. Mind it, a is not equal to 1. Here domain is 0 to infinity, and range is your real number. Now there are two cases here also. What are the cases? Number 1, if a is greater than 1, and another one is a lies between 0 and 1. Now here a is greater than 1, then the value of y similarly increases with increase in the value of x. Here the value of y increases with increase in the value of x. How it is? Y equal to log x to the base a. It is less than 0 if x is less than 1. It is less than 0 if x is less than 1. Now it is equal to 0 if x equal to 1. Here x equal to 1, and it is greater than 0 if x is greater than 0 if x is greater than 1. Second case is, so this graph is your y equal to log x to the base a, where what it shows if x is less than 1, then the value of y is less than 0. If x is equal to 1, the value of y is also if x equal to 0, value of 1, if the value of y is 0, and if x is more than 1, the value of y is more than 0. Second case, what we are coming, if a lies between 0 and 1, the value of y decreases with increase in the value of x. How it is? Y equal to log x to the base a. It is greater than 0. It is greater than 0 if x is less than 1. X is less than 1, it is greater than 0. It is equal to 0 if x equal to 1. See at this point, here 0, it is equal to 0 when x is your 1. And first condition is, if x is less than 1, it is greater than 0. It is equal to 0 when x is 1, and it is less than 0 if x is greater than 0. So these are two conditions. Now let us these are the conditions, and this is the graph of graphical representation of logarithmic function. What are the logarithmic function? When these two conditions, if a is greater than 0 and a lies between 0 and 1. Next, let us come to properties of logarithm. What are the properties of logarithm? You know it. Log 1 to the base a. So log 1 equal to 0, where a is greater than 0 and a is not equal to 1. A is not equal to 1. Log a to the base a equal to 1. That is log of any number to the base of that number is equal to 1, where a is greater than 0 and a is not equal to 1. Now, always a is positive real number. Now, log a mn, product of mn to the base a equal to log of m plus log of n, where mn, it is also greater than 0, a is greater than 0, but a is not equal to 1. Next is log coefficient, log m upon n to the base a, that is log of m minus log of n, where again coefficient m by n is greater than 0, a is also greater than 0, and a is not equal to 1. Same log m to the power n base a, that is n will come here, n log m to the base a, where a is greater than 0, m to the power n is greater than 0, and a is not equal to 1. Next comes log n x to the power m upon to the base a, that is m by n log x to the base a. So it becomes m by n log x to the base a, where a is greater than 0, here a is not equal to 1, and x is also greater than 0. So these are the properties of logarithmic function. Here ends the logarithm function. We end the types of function and their graphical representation. Now I will go to algebra of real function. So what are the algebra? We will go for addition, subtraction, multiplication, quotient, and multiplication of a function by a scalar. Now if let f1 d1 to d1 mapping function f d1 mapping to r and g function d2 mapping to r, two real functions. Domain is d1 and d2 respectively. Then algebraic operations are given by, first is addition of two real functions. What are they? If function f x mapping to r and function g x mapping to r be any two real functions, where this x is the subset of real number, then we define f plus g x mapping to r by the addition, that is addition of these two functions, f plus g x equal to fx plus gx, where all x belongs to small x belongs to capital X. That is addition of two functions is separated. Suppose f plus gx, so you write fx plus gx. Similarly, subtraction of one real function from another real function. Suppose again, if f mapping function f x mapping to r and function g x mapping to r are two real valued function, then such that capital X is a subset of a real number, then we define f minus g x mapping to r given by f minus gx equal to fx minus gx. That is, if that is subtraction of or the difference of these two functions with containing x is fx minus gx, where x belongs to your small x belongs to capital X. Now, then comes to multiplication of a function by a scalar. Suppose fx mapping fx mapping to r is a real valued function, and alpha be a scalar real number. This any alpha be a scalar real number. Then what we did, the product alpha f, that is product of alpha scalar with function f, is a function from x to r, and it is defined by alpha f x equal to alpha you take outside, then fx, where x belongs to small x belongs to capital X. Then comes your multiplication of two real valued function. What is multiplication? If suppose again function f mapping from x to r and function g mapping from x to r are two real valued function such that capital X is a subset of real number, then we define f by g, fg equal to x equal to, that is product of fg equal to fx dot gx, that is product of these two functions with the x, fgx equal to fx and gx of product, where x is a subset of capital X. Here, since it is pointwise equivalent, multiplication equivalent point, so it is also called pointwise multiplication. Pointwise, each and every pointwise multiplication, it is called pointwise multiplication. Now let us come to quotient of two real functions. The quotient of, if suppose again f two functions fx mapping to r and g mapping to r are two real valued functions such that capital X is the subset of real number, then we define this function f by gx equal to fx by gx, where gx is not equal, denominator cannot be 0. If denominator is 0, it becomes invalid. Gx is not equal to this, that is undefined, and x is a small x belongs to capital X. So these are the algebra of all real numbers. With this, I stop the this theory part of relations and functions. Now we'll go to exercises that we'll do. I'll do later some important questions of this relation function. Meanwhile, if you want the detail of this thing, then you can go to my education blog. Thank you very much.